Hello, friends. Part two of your podcast on section 6.3 in the Algebra 2 book. This is a more complicated than necessary explanation of what a composition of function is. This is a more appropriate example. So in this case, using my groovy color coding, here is my f of x. 6 times x to the negative 1. And remember, x to the negative 1 just means 1 over x, so this could also be written as 6 over x. This means the same thing as 6 times x to the negative 1. And my g of x is 3x plus 5. So when they ask me for f of g of x, what they're saying is take 3x plus 5 and put it in for x right here. So that's what I'm going to do. And so they're really asking for f of 3x plus 5. So here is the original part of f. And instead of an x, like they have up here, we're going to substitute in this 3x plus 5. So my negative, according to my negative exponent rule, I'm just going to move the 3x plus 5 down to the bottom. And the 6 is going to stay right on top because remember, 6 is just the same as 6 over 1. So that's what I have. That's the end of the story right there. All right. And I could do it in the reverse order as well, okay, which means I would take the 6 times x to the negative 1 and substitute that into my original g of x equation. So when I do that, you can see I'm going to multiply 3 times 6, and that's where I get the 18. That 5 is still outside, and so I get 18 over x by using that negative exponent rule again, plus 5. That's it. Now, if you do this, and these two expressions end up being x, then these are inverses of one another. We'll get to that later, though. All right, and these are the same kind of problems where you have to find the domain. So that's all the places that it works. And so we're, again, just concentrating on those two restrictions, one for the denominator can't be 0, and the other for the radicand of a square root can't be negative. So what do they do here? They say that because this denominator is 3x plus 5, that 3x plus 5 can equal 0. So they don't show it here, but what they did was they said 3x plus 5 cannot equal 0, and they solved for x. They subtracted 5 and divided by 3, and they got x cannot equal negative 5/3. So that's where this comes from. And they do the same thing here, except all I got to know is x can't be 0, the whole denominator. So that's why this can't be 0. So if I was going to write that in my fancy set notation, for the first one, I'd put all values for x such that x does not equal negative 5/3. Close it up. And for the second one, all values for x with a colon this time, such that x does not equal 0. So they say it in words up here, which is all fine if that's more comfortable for you, but I think the groovy set notation is better, especially for any of you guys that are going to be moving forward in math after Algebra 2. So by following those examples that you saw, you should be able to do this problem. So that's the other part of practice that you're going to get. So you're finishing your 6-2 worksheet, and you are doing problems 1 and 2 in this podcast. And we will see you Monday. Have a good weekend.